Good morning, everyone. Today we are going to delve into a critical operational challenge in the blast furnace management, the cook mess. We will be exploring its root causes, the immediate risk it poses, and the most importantly, the practical remedies and the long term strategies we can implement to prevent it. What is cook mess? So let's start by defining a problem. A cook mess is not just a minor inconvenience, it's a phenomena where a large quantity of coke is unexpectedly discharged along the hot metal from the taphole during casting. So this is a clear indicator of abnormal drainage or compromised taphole condition, signaling that smelting is wrong in the process. So, does this typically happen? A coke mess often occurs under specific circumstances. After a long furnace downtime, when a new taphole is installed or when poor quality clay is used, it can be unpredictable, and when it does happen, it frequently forces a temporary shutdown of the tapping stream or disrupting our entire operation. Now, to solve the problem, we must understand the root, and there are four primary culprits. First, low quality or poorly set clay lead to fast erosion and insufficient plug. Second, water leakage from system like wear accelerate coke erosion and weakens the clay plug. The third, the poor coke quality with weak structure mean it break apart easily. And fourth, a prolonged taphole opening with a wide short bore simply allow coke to wash out with the metal. The consequences are severe. A cook mess can suddenly choke the runner system, creating a major cleanup and safety hazard. It increases risk of splashing, stream explosion, and uh, jamming. We lose control of the hot metal flow, and it often point to deeper, more systematic health issue within the furnace itself. Coming to the prevention, where prevention start with the vigilance. Key monitoring activity include regularly checking the taphole length, the diameter before tapping, watching for signs of any water leak like steam or unusual flame color, and meticulously keeping record of tapping sequence and any past incidences. So when a coke miss happens, the response must be swift and precise. The immediate steps are the first, promptly plug the taphole with the fresh, high quality clay. Second, lower the blast vent volume to reduce pressure. Thus, isolate and repair any water leak immediately. And fourth, clean the cast house runner thoroughly before restoring to regular casting sequence. This throttling the wind is uh, has been mentioned due to only such take care of results such cast houses problems. Now, looking the long term, our strategies rest on the four pillar taphole management, that is using high quality clay and standardized plugging practices, water leak control. In these, through routine inspection and automated detection system, coke quality, coke quality assurance. In these, by monitoring strength and proper blending, and finally, operators training, it ensure our cast house team are prepared to respond quickly and safely. So let's dive deeper into taphole monitoring, why it is so essential. Properly monitoring the taphole geometry is critical for controlled drainage. It directly prevents cook mess, runner blockages, and dangerous eruptions. A correctly formed taphole bore minimizes the risk of excessive coke outflow. So, what are the best practices? We must measure the taphole length and diameter after every plugging and before every tap using calibrated rod or laser gauges. We also need to assess the plugging condition itself, checking the clay for integrity, ensuring it's free of crack, and confirming it has a cool property and it properly cooled without being water soaked. So be on the lookout for these red flags. A taffel bore that is short and wide, visible clay erosion or an incomplete plug in the taffel mouth, and any sign of water entry which can cause rapid clay disintegration. To systemize these, we recommend a technical workflow. Document every plugging event and any change in taphole geometry. Use this data for predictive maintenance and trend analysis. And finally, employ sensors for the real-time diagnosis in the taphole zone. The benefit of this rigorous approach are clear. It significantly reduces cook mess incidents and the risk of uncontrolled eruption. It supports safer, more efficient casting operation and extend the life of our taphole clay. Furthermore, it provides invaluable data for continuous process optimization also. Our objective is a secure seal. To assess this, we have five key criteria. One, clay integrity. It must be continuous and uniform. Two, clay quality using approved high quality material. And three, about the temperature profile. It should be cool, not overheated or wet. And fourth is plugging technique, ensuring full depth and a smooth column. And five is water gas detection, actively watching for steam and moisture. We have a several tools at our disposal: visual inspection, temperature sensor, depth gauges, detail logbook. The outcome of good assessment are a secure seal, longer clay life, fewer emergencies, and most importantly, safer, repeatable casting cycles. So let's look at some real world examples. In incident 1, a long outage led to coke mess. Upon reopening, the recovery involved immediate sealing and leak checks. Incident 2 was caused by poor quality clay fixed by switching to a better batch. Incident 3 was triggered by an undetected water leak resolved by isolation and repair. These cases highlight the diverse trigger we face. From these incidents, we have learned vital lesson. Rapid detection and plugging are key to minimizing downtime. High quality clay and vapor taphole, especially leakages in the taphole, are really very detrimental. And so high quality clay and proper taphole setting are not non-negotiable. Vigilance against water leak is critical and we must avoid a rush startup, ensuring our team are well trained and clear emergency procedure. In conclusion, the key takeaways are straightforward. A cook mess is largely preventable through vigilant monitoring and disciplined best practices. Investing in high quality clay, controlling water leaks, and managing the taphole carefully will drastically reduce cost and risk uh, also. And when an incident does occur, a quick, safe, and A standardized response is essential to protect our people and our productivity.